Alright, let's start with the lesson 3, continuity. Now this is a corollary we have to prove, which is based on the last theorem we done in the previous video, the very easy one. If f has a limit point at P, then this limit is unique. Okay, so let's start with the proof. Where P is a limit point of E, that is a subset of X. So let's take two metric spaces. Let X and Y be metric spaces. MS is referred to be as metric spaces, and E is a subset of X. And we are having a mapping from this E to Y, be a mapping, and this P is the limit point of E. Be a limit point of E. Fine, okay. If possible, suppose this limit is not unique. We are having the 2 points. So if suppose limit x tends to P, f of x is equal to q1, and limit x tends to P, f of x is equal to q2. Suppose this limit is not unique, where q1 is not equal to q. These are the distinct ones. Then I have to choose my epsilon positive. For that, I have to choose two deltas. One is for this delta 1 and the other delta 2 for the second one. Right? Okay. Then, for epsilon, I will take my epsilon later. Because epsilon must be positive, I must choose some epsilon. We are having, for epsilon positive, there exists delta 1 positive and delta 2 positive, such that the distances in Y distance in Y, what will be the distance? Yes, f of x comma q1. This distance will be less than this epsilon, which I have to take. And for all x belonging to E, okay, I must write epsilon first, for which distance in x comma P is less than delta positive. And the other distance, f of x with q2 is also less than epsilon for all x belonging to E. I must give some space. Later on you will get to know why. For which distance in x is less than delta. This is delta 1, this is delta 2. Fine. I must choose delta to be the minimum of this. Choosing delta to be the minimum of, delta 1 and delta 2. Fine. Okay. Now what should I take my epsilon? I have to prove the result. So because there is a talk for the distance, so I let my epsilon to be equal to distance in Y between q1 and q2 divided by 2. Taking my epsilon to be this. later on you will get to know why I have taken the epsilon to be, because epsilon is positive and the distance in y between q1 is also the point of y, q2 is also the point of y, and these two are distinct. So this distance by 2, I take this epsilon. Now this epsilon work for 1 and 2. Okay. So distance for distance in y fx comma q1 will be less than this epsilon. That is distance between q1 q2 over 2. And also this same epsilon works for the second one also. q1 q2 over 2. Okay. Right. Now choosing this delta to be equal to this, then distance in y f of x comma q1 will be less than my epsilon, which is distances in y q1 q2 by 2, right? And same distance in y fx comma q2, this is also less than distance in y q1 q2 over 2, the same epsilon for all x belonging to E, for which, because I take my delta to be the minimum of delta 1 and delta 2, so for which my distance in x comma p is less than delta. Right? So I combined. Next. Okay. By triangular inequality, I'm having distance in y q1 comma q2. This is less than equal to taking distance in y q1 with f of x plus distance in y f of x with last point is q2, so q2. Right? Now you get to know why I have taken my epsilon to be distance q1 q2 by 2. See, the first distance is less than this epsilon and the second distance is less than this. There is nothing, if you suppose this is one and the same thing, dy of fx comma q1, or you can also write as dy of q1 comma fx, this is one and the same thing, right? This is just the distance between the 2 points. So fx can be here or here, it doesn't matter. This distance is less than epsilon. My epsilon is q1 comma q2 by 2. And this distance is also less than epsilon. And here also my epsilon is q1 comma q2 by 2. For distance in x to be x comma p less than delta. Now what this equal to? This will be equal to, if we add these two, I am getting distance q1 comma q2. Will this possible that this distance q1 comma q2 is strictly less than the distance, same distance q1 comma q2, which looks so absurd. So which is not possible? Which is strictly not possible. That's why I have taken my epsilon to be distance q1 q2 by 2. Okay. Now you got to know why I have taken this epsilon to be equal to this. So here contradiction comes. So our supposition was wrong. The limit which I have taken, that limit must be unique. So that limit is unique. Our supposition was wrong. So hence then limit x tends to p f of x is only unique. That means Q1 and Q2 are one at the same point. So this limit is unique. Fine. So thank you for watching this video. In the next video, I will be going to start a new topic, continuous functions. Right? Till then, bye. Have a good day. Have a lovely day. Enjoy your day. God bless you all, my students. Goodbye.